Hello, my name is Chris Keyack with Keyack Technology Solutions. I'm a Tekla Structures developer and trainer and consultant. And in this video today, I'm going to showcase a new tool that I created for a customer that generates a bridge cross-frame elevations based on data that has been defined in Microsoft Excel. Now, before I actually put in the bridge frame builder in the cross section, I want to explain that I use building block custom components oftentimes with clients, and I wrap those up into my API plugins. So what do I mean by that? Well, first here, if I double click on this, this is actually a custom component part that I created with a customer. It doesn't require programming. Now, it does have logic and a lot of variables and things in here, so I wouldn't say that this is a beginner custom component by any means, but it didn't require programming, and the customer has taken ownership of this, and they maintain and modify this as required. So without having to be a programmer, they can somewhat be in control of their destiny and build additional custom components like they did here for the other frames. Now, here I also have a girder stiffener custom component that does the stiffener plates or the connection plates in the girders here. And I built this to be parametric, and there's different fields and properties. And basically what I do is when these custom components are built, I use the API with Tekla Structures to then use those as building blocks and call those and set parameters from the Excel spreadsheet to actually input that and do the entire bridge cross frame, which is what we're going to see here. Now, what I'll do is I'll go ahead and open up my bridge frame builder plugin, which is done with the API, and I can browse to my spreadsheet. So here it's inside my model folder, so I can just browse to that. And then I can tell it to load default save settings from the components for things that are not inside of the Excel spreadsheet. Well, what do I mean by that? If I go here to the part properties, there's a lot of stuff in here like the part prefixes and the start numbers and things like that that have nothing to do with the actual bridge design itself. It's more fabrication information. That information can be saved away as standard in the component, and then that data can then be called by my API plugins for things that are not defined inside the spreadsheet. So that just kind of shows you what that option there is for. Now, before I actually go in here, or no, you know what I'll do is I'll actually put it in. So let's just put this in. I'll pick my first point, which is my origin here at the center of the first girder. And the second point is just basically define the orientation in which the cross frame will be drawn in the model. And there within seconds, it actually read the spreadsheet and it put everything in here. And you're going to see these cones because it put in those custom components to do the seams, and then it did the custom component part for the frames. And then you can see that it's actually putting in the bolts here and has everything input. Now, the bridge girders, they're not full-fledged detailed bridge girders. They're really there for reference. So if I actually came in here and go to view list, and opened up my elevation on grid line 2 where I can see this actual cross frame, traditionally a bridge detailer would actually lay this out in AutoCAD. They would draw in the girders and do this cross section, draw in all the angles, do the layout geometry based on the design drawings, and then they would make sure that all of this is working, and then detail the girder, stiffeners, and the gussets for the frames all kind of together in a layout. Here, what we're doing is we're accelerating that process. Instead of a lot of manual layout in Tekla and putting that in, we're just basically inserting these custom components and reading data from the Excel spreadsheet. So let me show you how this works. Right now I can tell that in the Excel spreadsheet I had a lot of 0 setbacks and 0 offsets here for my work points to interface between where the diagonals and the laterals come in here to the stiffeners. So let's actually show how this works with the Excel spreadsheet. All right, so I'll go up to my model folder, open the model folder, and I've got my Excel spreadsheet here. So I'll just go ahead and open this up. And then what I can do is there is basically the way this is organized is there's each of the girders, and then the frame that is spanning between there, each of the girders is in the middle. And so the customer really came up with this format. Most bridge detailers and fabricators, they have extensive Excel spreadsheets that they populate data and do a lot of geometry calculations for. And so I didn't want to replace that and make a very detailed kind of user interface in Tekla. I'm just going to let them work in the environment that's familiar and then map that data into the plugins in Tekla automatically. And this customer did a really good job. They made it very easy for me to follow. They actually have pictures with each of the fields, so I knew what I needed to map. And this really makes it easy for me as a developer when the customer sort of kind of gives me the narrative of exactly what data is supposed to go where. So what I'm going to do is I'm going to just change this angle setback field. So here on the frame itself, I can come in here and put in 3.5 or 3.5 inches, and then I'll just do that on each of these. Okay, and so when that's done, I will save the spreadsheet, and I do need to close it so that way Excel is not keeping this file open and read only, and so that way the plugin can interpret it. So I'll then just go back in here, double click and press modify, and it will reread from the spreadsheet, and then it will change the setbacks. So now you can see that there are setbacks on all the braces. Now, I do need to control the work points, and this was not currently in the spreadsheet. So this is where I can actually go back into the cross frame, and then I can enter in some dimensions here to offset the diagonal work points from the bolt work points for the lines of the geometry between the laterals and the diagonals. So to do that, I can just put in here, like say -4, just on both sides. And then I can come in here and I can put in, I think I had like 5.5 or something in here to make this work. And then I'll just save that as standard up at the top. Okay, so I'll press OK and interrupt. Then I'll just go back into the plugin itself and press modify, and it's going to reread those. And look at that. See, it offsets the diagonals based on those work points from the save standard files. So it can be a combination of data that's in the spreadsheet for design information and parameters that need to come from there. And if there's just detailing standards that the detailer needs to make discretionary like updates and changes on, they can save those settings away, and the plugin will load and read both the spreadsheet and those standard settings. Again, my name is Chris Keyack with Keyack Technology Solutions, and I've got over 20 years of working with Tekla Structures as well as a steel detailer. And if you need any custom developed tools built on top of Tekla Structures, feel free to reach out to me, and I'd be happy to look at what solutions we can provide.